Okay, this video will be talking about comparing two different sets. Whereas in the last video we had a thing and a set, and the question was, is this thing in that set? We call that an element. This will be on both sides of the question will be sets, not a thing and a set, but a set and a set. So the first thing is a very simple one, equality. Are the two sets equal? Well, yes, if they have exactly the same elements. So the order of the elements doesn't matter, which you're seeing in my first example. The way in which you describe the set does not matter. For instance, I have no dogs, so the set to the left of the equal sign has nothing in it. And by definition, the set on the right also has nothing in it. So, yeah, they're considered to be equal. What's the English saying they have exactly the same elements when neither has an element? It's a little bit strange, but yes, an empty set is considered to be equal to itself. Now, if the set on the left has more things than the set on the right, or vice versa, that's not equal. That's what we're going to get into in the next slide. Okay, subset. So, if set B has everything set A has, and maybe a little bit more, then A is inside of B. And the term we call that is subset. A is a subset of B. Now, if they're equal, they're subsets. B does not have to have extra stuff. So they could be exactly the same stuff, and they're subsets. And actually, in that case, B would be a subset of A, and also A would be a subset of B. And then we have to have this special little part of the definition for empty sets. Empty sets is a subset of every other set you can possibly imagine. Okay, now, sometimes we distinguish between things that are subsets and things that are equal. So we have this word called, or this term called, proper subset. So it's a subset, but it's not equal. So B does have additional stuff. So here we have a set of all the dogs in the world, and the set of all the animals in the world. And because dogs are animals, yes, the set on the left is a subset of the set on the right. Now notice with the symbol up here, when we're just saying subset, we do have the additional line underneath that's kind of like half of an equal sign. So that extra line says, yeah, they might possibly be equal. Whereas in this symbol, there is no line underneath. So no, they may not be equal. If you're using this symbol, you're saying they are not equal. You're saying the thing on the right has everything that the left has and more. Okay, now we have some pictures to talk about relationships between sets. What we're talking about with subsets. The blue set is inside of the red set, or maroon set. If one thing is a subset of the other, we just draw one circle inside of another. Or sometimes they're ovals instead of circles. Okay, if there's some overlap, and I don't have these pictured, but if set A and B have some things in common, but A has things B doesn't, and B has things that A doesn't, then we just show them overlapping, not one completely inside the other, but just there's some kind of overlap. And if they have nothing in common, so if we have the set of plants and the set of animals, then the two circles have no overlap. They're just two circles sitting in space, completely unrelated to each other. And the term for that is, we say that the sets are disjoint. Excuse me. Okay. Lastly, back on the subject of subsets, we can count how many subsets a set will have. So first of all, we have the symbol. If we put bars around a set, we're talking about the number of things in the set. technical word for that is the cardinal number of the set. Then, if the number of things in a set is n, then 2 raised to the power n is the number of subsets. So here's an example. A is 1, 2, 3. Obviously, A has 3 elements, or bar A equals 3 would be another way I could have written that. So, according to this formula, 2 raised to the power 3, that comes out to be an 8, is the number of subsets that A has. And here I've listed out all 8 subsets, so you can check for yourself. Okay, that's it for comparing sets.